This one's a little bit different than when the light's on the ground. Okay, this also, it doesn't make any sense. I don't know why I typed these up like this, but you got a super tall friend who happens to be 7 feet 8 inches tall, and he's running because he's crying because he's so tall, and the short kids made fun of him, and he's running towards a lamp. All right, he's running towards a lamppost, and as he runs towards the lamppost, his shadow is on the ground behind him. Okay, and as he runs towards this lamppost, the closer he gets to the lamppost, the shorter his shadow should be. Okay. So if we draw this, you can imagine here that if the lamppost is up here and it is 20 feet tall. What? That's a lamppost. Okay? Use your imagination. Okay. And our friend is over here, and here's the ground, and the light is shining down on him like this. Much like the light of heaven, yes. And that's putting a shadow on the ground behind him. Okay? So notice that in this one, different than the last one, the vertical height is not changing now because the lamppost is in the air. It's 20 feet in the air. What's changing now is both the lengths on the ground. Right, Joseph?
Yes.
Yeah? So we also, in the last problem, we knew that this length here was a fixed distance. Okay? But in this problem, that's not true. Because what's happening is, as the person moves towards the light this way, both are getting smaller. So it's not a fixed distance. So we need to give them both variables. We can't do like the 40 minus x trick. So I usually call the shadow just h. And then I'll call this distance here x. Okay? We also know that our friend is 7 feet 8 inches, but we got to put that all in feet. We can't have 7 foot 8 inches. So it's 7.6 repeating, or as a fraction, which is preferable, it's 7 2/3 feet, which is the same thing as 23/3 feet. What is going on, pen? Okay. So we have 23/3 feet there. And that's our friend, sobbing his little eyes out. I know, right? Okay. No, he's really disproportionate. It's weird. He's Asian. Okay, that's enough of that one. All right. Good Lord. Yeah. What do we know? What rate of change? So obviously they tell us how fast something's changing here. What's our rate of change in this problem? 5 feet per second. What is that the rate of change of? Which one?
H.
It's x. It's not h, it's x. Okay? Because he's running towards that light. That's how fast x is changing. So we know dx dt is -5. And that's feet per second. Okay? So because we know dx dt and we want to know how fast his shadow is changing, well, that's dh dt. We just need an equation linking them together. Okay? So in a situation like this, in a question like this where they put the light in the air and the shadows on the ground, it's easiest to set up, it's still going to be similar triangles. It's almost the same as that drawing. It's just different things are changing. Okay? It's easier to set this up as, I'm going to do h divided by 23/3. Okay? So that's a smaller triangle. So we're going to do h over 23/3 has to be equal to, in the bigger triangle, the base is x plus h over 20. Okay? And before I derive this, we can derive this the way it is right now if we really wanted to, but I'm going to simplify because it's going to make it a whole lot easier. You guys are going to love this. This is super easy to do at this point. Number one, h divided by 23/3 is the same thing as 3h divided by 23. It just puts the 3 in the numerator. And this is the same thing as 1/20th x. You know what? Let's not even write it like that. Sorry. Yeah, let's just leave it like that. We're just going to cross multiply. X plus h over 20. Again, so before we derive it, I'm going to get rid of all the fractions by cross multiplying. And when you do that, you're going to get 60h is equal to 23x plus 23h. I'm just going to get all my h's together. So that is 37h must equal 23x. And look how easy that is to derive. When you derive the left side, you're just going to get 37 dh dt. And that's going to equal 23 dx dt. And it turns out h and x both just go away. It doesn't even matter what they are. Okay? We knew dx dt from the beginning was -5. So we're basically done. dh dt. We're going to plug in -5. And -5 times 23 is -115. And then you're going to divide that by 37. And that's in feet per second. So that's how fast the shadow on the ground is shrinking. Woohoo!